particle projected with a velocity ui plus uj meters per second from a fixed point O in a horizontal plane landed at a point in the same plane 360 meters away. Find the value of u and the projectile's path's greatest height h. Take g equals 9.8 meters per square second. When dealing with projectile motion, it can be really useful to sketch a diagram. We know that the motion of the particle will look a little bit like this inverted parabola. We're also told that the horizontal and vertical components of the initial velocity are both equal to u, so we can drop in a right-angled triangle as shown. We also know that the particle lands 360 meters away, so that means the final horizontal displacement of the particle is 360 meters. We also have acceleration due to gravity that acts downwards. So in order to answer these questions, we're going to use the equations of constant acceleration, sometimes called the Suvat equations. But we're going to separate these into the horizontal and vertical motion of the particle. We'll begin with the horizontal motion. Initial velocity in the horizontal direction we're told is equal to u. We also know that horizontally there is no acceleration, so that's 0. And this means that its horizontal velocity, until it reaches the ground at least, will always be equal to u. We're going to use the final horizontal displacement to help us calculate a few other bits of information, and we know that's equal to 360. We don't yet know anything about the time. We'll now consider the vertical motion. The initial velocity vertically is u. We're told that acceleration due to gravity, which we've labelled g, is 9.8. Now that acts in the opposite direction that we've defined the vertical velocity to be in, so we're going to say that's negative 9.8. We don't yet know anything about the vertical velocity at a given time, but we do know that when the particle hits the ground, its vertical displacement must be equal to 0. And we don't yet know the time at which this occurs. We do, however, have enough information to help us find the value of u. Let's list those Suvat equations. We have v equals u plus at, s equals ut plus a half at squared, s equals a half u plus v times t, v squared equals u squared plus 2as, and s equals vt minus a half at squared. We're going to begin by looking at the horizontal motion. And we're going to use the third equation, s equals a half u plus v times t. This will tell us the value of t, the time that the particle is in motion. We get 360 equals a half times u plus u times t, or simply 360 equals u times t. By dividing through by u, we find that t is equal to 360 over u. This remains consistent in the vertical direction. Remember, we're looking at the point that the particle hits the ground again. This time we're going to use the second equation. We're not really interested in the vertical velocity. We get 0 equals ut plus a half times negative 9.8 t squared. A half times negative 9.8 is negative 4.9, and then we can replace t with 360 over u. These two u's cancel. We then add 4.9 times 360 over u squared to both sides, then multiply through by u squared and divide through by 360. So we get u squared is equal to 4.9 times 360, which means u is equal to the square root of 4.9 times 360, which is equal to 42. Now here we were only interested in the positive square root, since we define the initial horizontal velocity to be positive. And so u must be equal to 42 meters per second. The second part of this question asks us to find the projectile's path's greatest height. Now there are a couple of ways that we can do this, but we can redefine a few elements in the vertical direction. We're no longer interested in the horizontal motion. We know that u is equal to 42. The height we're interested in is h. We don't know the time at which this occurs, although we could work it out by finding the total time taken and then halving it. Alternatively, we recognise that at the moment that the particle reaches its highest height, its velocity in the vertical direction is 0. And so we find the equation which does not include t. It's v squared equals u squared plus 2as. Substituting what we know about our particle, we get 0 squared equals 42 squared plus 2 times negative 9.8 times h. 42 squared is 1,764, and 2 times 9.8 is 19.6. So we add 19.6h to both sides, and all that's left to do is divide through by 19.6. That gives us a value of 90. And so we can say that u is 42 meters per second, and the projectile's path's greatest height h is 90, or 90 meters.